Mercury lies, gold sweats, miners inhale, millions poisoned. Nobody warns them. Mercury doesn't turn into a sponge, it disappears completely. What's left behind is something far more disturbing. 10 to 15 million people touch this metal daily. They're told mercury traps gold safely, forever. That belief has poisoned entire river systems for decades. In 80 countries, this harmless trick still runs today. 1 gram of mercury can contaminate a whole lake, yet miners heat it over open flames unprotected. The vapor released is invisible, odorless, and lethal. What forms after mercury vanishes is called sponge gold. It's porous, fragile, and worth more than the mercury. But the sponge isn't mercury, it's what mercury leaves. This single mix-up has confused people for generations. Today we're correcting it, atom by atom. You'll learn why gold bonds with mercury at all. The answer involves physics most people never study. It's called relativity, yes, Einstein's relativity inside a metal. You'll also learn why this trick still can't be replaced, despite cleaner methods existing for over a century. By the end, you'll see mercury completely differently. Not as a liquid metal, as a chemical trap. A trap that built empires and destroyed bodies. Stick around, because the real story starts underground, where a shining ball of poison meets pure gold, and only one of them survives the fire. Start with a shining silver liquid, elemental mercury. Miners pour it directly onto crushed gold-bearing rock. Gold is nearly unreactive, it resists acids, oxygen, rust, yet gold dissolves almost instantly the moment mercury touches it. This is called amalgamation, one of chemistry's oldest tricks. Mercury and gold form a soft silvery paste together. That paste is called amalgam, not pure gold yet. The resulting balls contain 40 to 80% mercury. They look solid, but they're a metal alloy, not a compound. Miners hand-shape these amalgam balls after separating them from rock. Next comes the most dangerous step in the entire process. The amalgam ball gets heated above 400 degrees Celsius. At that temperature, mercury doesn't burn, it evaporates. Mercury boils at 357 degrees Celsius normally. Open flames push it well past its boiling point instantly. The mercury doesn't disappear, it becomes invisible, toxic gas. What remains behind is a porous lump of gold. This lump is called sponge gold by miners worldwide. It earned that name from its holes and texture. Those holes are simply where mercury atoms used to sit. As mercury escapes, it leaves microscopic empty pockets behind. The gold left behind isn't perfectly pure, though sponge gold typically measures 16 to 22 carats. Some mercury always stays trapped, unable to fully escape. That's why sponge gold looks dull, not shiny like jewelry. It needs further refining before becoming usable, sellable gold. So the myth, mercury turns into a sponge, is backwards. Mercury never becomes solid sponge, it becomes airborne poison. The sponge you see is gold, wearing mercury's old shape. Every hole in that gold marks where danger escaped. And that danger doesn't just vanish into nothing, it travels through air, lungs, soil, and water systems. A single heating session can release grams of mercury vapor. Indoors, with no ventilation, exposure spikes to extreme levels. Miners often work barehanded, close to the open flame. Many don't know the vapor they're breathing is invisible. Mercury vapor has no smell, no color, no warning sign. That's precisely what makes this metal so deceptively dangerous. You can't see the moment you're being poisoned. This entire process has existed for over 2,000 years. Ancient Romans used mercury amalgamation to extract gold. Colonial mining operations scaled it massively across the Americas. Countless enslaved and indigenous workers died from exposure. Modern artisanal miners repeat almost the identical ancient method. Technology changed everywhere else, this process barely moved. Today, roughly 1,600 tons of mercury get used yearly. That's for small-scale gold mining alone. Worldwide, it makes small-scale mining the largest source of mercury pollution globally, larger than industrial coal plants, cement, or chlorine production. One ancient shortcut is now polluting an entire planet, and it all hides inside a harmless-looking gold sponge. Why does gold dissolve in mercury but not in acid? The answer starts inside the atom's electron cloud. Gold's outer electrons move incredibly fast, close to light speed. Einstein's relativity says fast-moving electrons behave differently than expected. This is called the relativistic effect, and it's measurable. It pulls gold's outer electron orbitals surprisingly close inward. That shift changes how gold absorbs and reflects light. It's a real reason gold looks golden, not silver. Without this effect, gold would look far more silvery white. Mercury experiences an even stronger version of the same effect. Its electrons move so fast they weaken atomic bonding. That's a key reason mercury stays liquid at room temperature. Nearly every other metal on Earth is solid instead. So gold and mercury share a strange atomic trait. Both are shaped by the same relativistic physics. This shared distortion makes them chemically compatible partners. Mercury atoms slip easily between gold's loosely packed structure. No true chemical reaction occurs. It's a physical alloy. That's the technical difference between amalgamation and true bonding. Amalgams form through diffusion, not electron sharing or transfer. Mercury essentially dissolves gold the way water dissolves salt. But not every metal falls for Mercury's atomic trick. Iron strongly resists forming an amalgam with mercury. That single fact quietly shaped Mercury's entire industrial history. Mercury has been shipped in iron flasks for centuries. Because iron containers barely react or corrode from contact, platinum also resists amalgamation more than gold or silver. Silver, tin, zinc, and copper amalgamate fairly easily though. That's why old dental fillings used silver-mercury amalgam blends, the same chemistry that extracts gold once filled teeth. Dentists relied on amalgam's softness before it hardened permanently. It's the identical bonding principle, just a different application. This is a reason mercury thermometers use glass, never metal. Metal casings risked slowly reacting with the mercury itself. Chemists call this general phenomenon wetting a metal surface. Wetting happens when mercury's atoms bond stronger than cohesion. Gold offers a favorable atomic gap size for mercury. Too small a gap, and mercury simply can't penetrate. Too large a gap, and the bond stays weak, temporary. Gold's atomic spacing sits in a useful middle range. It almost looks like these two metals were made for each other. They weren't. It's a coincidence rooted in atomic structure. Gold sits at atomic number 79 on the table. Mercury sits directly next to it, at 80. Their neighboring positions create similar relativistic electron behavior. This isn't folklore, it's measurable. Tested quantum chemistry. Yet for centuries, miners used this bond with zero explanation. They just knew mercury grabbed gold, and that was enough. Science eventually caught up to explain an ancient observation. Understanding why doesn't make the process any less dangerous. Every gram of vaporized mercury has to land somewhere. Rain carries it from the air back into rivers and soil. Bacteria in water convert it into methylmercury, a neurotoxin. Methylmercury is far more toxic than elemental mercury itself. It travels up the food chain through fish easily. Large predatory fish accumulate the highest concentrations of all. Humans eating that fish absorb concentrated methylmercury directly. 1956. This exact chain sickened an entire Japanese city. A chemical company dumped mercury waste into Minamata Bay for years. Local fish absorbed it, and residents ate that fish daily. Thousands developed tremors, slurred speech, and lost motor control. Some couldn't walk, speak clearly, or control their limbs. Children born to exposed mothers suffered permanent brain damage. Some babies showed severe disabilities, though mothers seemed symptom-free. This tragedy became known worldwide as Minamata disease. It proved mercury doesn't stay contained where it's released. Today, artisanal gold mining repeats a smaller version constantly. Miners breathe vapor directly, at far higher concentrations. Pregnant women near mining sites face the highest risk. Mercury crosses the placenta and can damage developing fetal brains. Children in mining towns show measurable cognitive impacts already. Nervous system damage from mercury is often permanent, irreversible. Symptoms include tremors, memory loss, and personality changes. Severe cases cause kidney failure and motor breakdown. Unlike some poisons, mercury builds up slowly and silently. Miners may work for years before symptoms even appear. By then, significant neurological damage has already occurred. Global treaties eventually tried addressing this exact crisis. In 2013, an international mercury treaty opened for signature. It's called the Minamata Convention, named after that tragedy. It aims to reduce mercury use in trade worldwide. Yet enforcement in remote, informal mining regions remains extremely weak. Economic pressure keeps miners choosing mercury over safer alternatives. Mercury is cheap, fast, and requires almost no equipment. Safer methods exist, but they demand money miners don't have. One alternative is called the borax method, mercury-free entirely. Borax lowers gold's melting point without releasing toxic vapor. Some regions have successfully adopted it as a cleaner replacement. Another option is the retort, a simple sealed container. Retorts trap mercury vapor instead of releasing it outward. They can recapture the large majority of mercury used. That mercury can then be reused for future amalgamation. Despite this, most small-scale miners still skip retorts entirely. Culture, habit, and lack of training keep old methods alive. So the sponge and sponge gold still hides a real cost. Every porous gap represents mercury that had to go somewhere. It didn't vanish, it moved into air, water, people. This is chemistry with consequences stretching across generations. Understanding the reaction is easy. Undoing the damage isn't. That's the real story hiding behind a shiny gold sponge. So mercury never becomes a sponge. Remember that. The sponge is gold. Mercury's ghost living inside it. Every hole tells a story about invisible escaped poison. This tiny myth reveals something much bigger about chemistry. Elements don't just react, they leave fingerprints behind. Reading those fingerprints is literally how forensic chemistry works. Gold's relativistic bonding, mercury's toxicity, all measurable, all real. None of this required guesswork, it required careful observation. That's the actual power hiding inside basic chemistry. It explains ancient practices and modern global health crises. It connects Einstein's physics to a miner's daily reality. Science isn't separate from human consequences, it's tangled with them. Next time you see gold jewelry, remember its complicated past. Some of it likely passed through Mercury's dangerous embrace. Refining technology has improved, but old methods still persist. Millions of miners still repeat this ancient process today. Understanding chemistry doesn't fix mining economics or global poverty, but awareness is always the first step toward real change. If this surprised you, you probably assumed Mercury just disappeared. Most people do. That's exactly why the myth persists. Chemistry rewards curiosity and punishes convenient, comfortable assumptions. There's always a hidden mechanism beneath a strange transformation. Mercury didn't defy chemistry here, it perfectly followed it. The real surprise was our own misunderstanding, not the metal. If you want more myths broken down this precisely, stay close. Next time we're dissolving another impossible chemical reaction, fact by fact. Subscribe if you want real chemistry, not recycled internet trivia. Drop a comment. What element do you want investigated next? Somewhere right now, another sponge is quietly forming from fire. And now, you finally know exactly what it's hiding.